Hello and welcome. My name is Bob Tickleman. I'm excited to be your guide for AZ-500, Microsoft Azure Security Technologies. We're in learning path for securing Azure using Microsoft Defender for Cloud and Microsoft Sentinel, and specifically on module number 3, configuring and managing security for using Microsoft Defender for Cloud. By enabling Microsoft Defender for Cloud, you will enable the workload protections offered by it and start a key component to your cloud security strategy, ensuring that your workloads are protected from the various threats. Microsoft Defender for Cloud provides a unified view into the threat detection and protection for all protected resources. This includes virtual machines, SQL databases, containers, web applications, and more. The Interactive Workload Protections dashboard allows you to see the status of your resources and take the necessary actions to secure them. The Defender for Cloud coverage section of the dashboard allows you to see the types of resources in your subscriptions that are eligible for protection. When Defender for Cloud detects a threat, it generates an alert. These alerts provide details about the affected resources, suggested remediation steps, and sometimes an option to trigger a logic app in response. This helps you respond quickly and effectively to potential threats. The Insights section provides news, suggested reading, and high-priority alerts relevant to the environment. Microsoft Defender for Server protects both Windows and Linux virtual machines across Azure, AWS, GCP, and on-premises environments. This provides actionable recommendations to help remediate vulnerabilities and enhance your overall security posture. Defender for Server supports both agentless and agent-based scanning. Agentless scanning is enabled by default and provides vulnerability assessment, malware detection, and software inventory without the need of an agent on the endpoint. This helps maintain security without impacting performance. Defender for Server integrates seamlessly with Microsoft Defender for Endpoint, providing endpoint detection and response, or EDR, capabilities leveraging advanced threat intelligence and analytics to detect and respond to threats in real time. Defender for Server offers two plans, Plan 1 and Plan 2, with Plan 2 including additional features such as the agentless scanning, malware detection, and file integrity monitoring. It's important to choose the plan that best fits your security requirements. Microsoft Defender for Storage provides advanced threat detection capabilities for Azure Blob Storage, Azure Files, and Azure Data Lake Storage. It uses Microsoft Threat Intelligence, Microsoft Defender Antivirus, and sensitive data discovery to identify and mitigate potential threats. Defender for Storage also includes sensitive data threat detection, which helps prioritize and examine security alerts based on the sensitivity of the data at risk. The Sensitivity Data Discovery Engine in Defender for Storage is integrated with Microsoft's Purview sensitivity information types and classification labels. This ensures that the detection and protection of sensitive data aligns with your established policies and procedures. Defender for Storage is an agentless solution, and it makes it easy to deploy and manage at scale. One of the key features of Defender for Storage is its ability to scan for malware in near real time. This includes scanning all file types, including archives, to detect and prevent malicious content from being uploaded to your storage accounts. When malware is detected, Defender for Storage can take automatic actions such as quarantining the infected files or alerting administrators. While the malware scanning feature is designed to have minimal impact on performance, it's important to monitor the performance of your storage accounts and adjust the scanning settings if necessary. The sensitive data threat detection is powered by an agentless engine that uses a smart sampling method to find resources with sensitive data. It's integrated with Microsoft's Purview sensitive information types and classification labels, ensuring that the detection and protection of sensitive data aligns with your established policies and procedures. Upon enablement, the engine initiates an automatic scanning process across all supported storage accounts. Results are typically generated within 24 hours, and newly created storage accounts under protected subscriptions are scanned within 6 hours of it being created. By default, recurring scans are scheduled to occur weekly after the enablement date. To enable sensitive data threat detection at the subscription and at the storage account level, you need to have the relevant data-related permissions from the subscription owner or the storage account owner roles. Azure policies define and enforce policies across your Azure environment. These policies ensure that resources adhere to specific rules and guidelines, helping to maintain compliance within the organizational standards and regulatory requirements. A policy definition specifies the condition under which a policy is enforced and the actions to take when these conditions are met. Policy assignments determine where the policy takes effect, such as individual resources, resource groups, subscriptions, or management groups. Azure security initiatives are collections of related policy definitions bundled together for specific purposes, such as achieving compliance with industry or government standards like GDPR or HIPAA. Initiatives simplify the management of multiple policies by grouping them into a single item. It's recommended to enable Defender for servers at the subscription level to ensure that all existing and new virtual machines billed to that subscription are automatically protected. Integrate Defender for servers with Microsoft Defender for Endpoint to leverage advanced threat intelligence and analytics. This integration provides endpoint detection and response, or EDR, capabilities, enhancing your overall security posture. Using the security posture management features to get actionable recommendations for remediating vulnerabilities and improving the security of your VMs. Agentless scanning is enabled by default and provides vulnerability assessments and malware detection and software inventory without the need of an agent at the endpoint. This helps maintain security without impacting performance. Similar to Defender for servers, it's recommended to enable Defender for databases at the subscription level to ensure comprehensive coverage for all databases and enable and configure vulnerability assessments to identify and remediate potential security issues in your databases. This helps maintain a secure and compliant database environment. Be sure to regularly monitor security alerts generated by Defender for databases. These alerts provide details about potential threats and suggested remediation steps, helping you respond quickly and efficiently. It's recommended to enable agentless scanning at the subscription level to ensure comprehensive coverage of all existing and new VMs. Agentless scanning is available in both Defender for Cloud Security Posture Management, or CSPM, and Defender for Servers on Plan 2. Ensure you select the appropriate plan that includes agentless scanning capabilities. Agentless scanning uses cloud APIs to collect data by taking snapshots of VM disks. These snapshots are analyzed out of band, meaning the VM performance is not impacted. The copied snapshot is deleted immediately after the necessary metadata is acquired. A log analytics workspace is a unique environment for Azure Monitor log data. Each workspace has its own data repository and configuration, and data sources and solutions are configured to store their data in a particular workspace. To create a log analytics workspace, navigate to the Azure portal, select Create a Resource, and search for the Log Analytics workspace. Follow the prompts to configure the workspace settings. Once the workspace is created, you can connect the various data sources such as Azure resources, on-premises servers, and custom logs. This allows you to collect and analyze data from multiple sources in a centralized location. Configure your data collection rules to specify which data is collected and how it's processed. This includes setting up data collectors for performance counters, event logs, and custom logs. Use the Log Analytics Query Language, KQL, or Kusto Query Language, to query and analyze the data stored in your workspace. This allows you to gain insights into your environment and identify potential security threats. Data retention in Log Analytics Workspace refers to the period during which collected data is stored and available for querying. Managing data retention helps balance the need for historical data with storage costs and compliance requirements. To configure data retention, navigate to the Log Analytics workspace in the Azure portal, and under the Usage and Estimated Cost section, you can set the retention period for your data. The default retention period is 30 days, but it can be extended up to 730 days based on your requirements. Retention policies allow you to specify different retention period for various types of data. For example, you might want to retain security-related logs for longer periods of time compared to the performance metrics. Configuring retention policies helps optimize storage and ensures compliance with organizational standards. Longer retention periods can lead to higher storage costs. It's important to monitor and manage these costs by regularly reviewing your data and your retention settings and adjusting them as needed. Azure provides tools for estimating and managing storage costs associated with your data retention. So ensure that your data retention policies comply with relevant regulations and organizational standards. This includes retaining data for the required period and securely deleting it when it's no longer required. Consider using data archiving solutions for long-term storage and historical data. Archiving helps reduce the cost while ensuring that important data is retained for compliance and analysis purposes. The Azure Monitor Agent collects monitoring data from the guest operating systems of Azure Virtual Machines, scale sets, and Arc-enabled servers. It delivers this data to Azure Monitor for use by features, insights, and other services such as Microsoft Sentinel and Microsoft Defender for Cloud. The Azure Monitor Agent can be installed using various methods, including the Azure Portal, CLI, PowerShell, or ARM templates. This flexibility allows you to deploy the agent at scale across multiple environments, and DCRs, or data collection rules, define what data should be collected, how it should be transformed, and where it should be sent. DCRs provide consistent methods for configuring different data sources and allow you to apply transformations to filter or modify incoming data before it's stored. The Azure Monitoring Agent integrates seamlessly with other Azure services such as Microsoft Sentinel and Microsoft Defender for Cloud. This integration enhances your ability to monitor and secure your environments by providing comprehensive insights and advanced threat detection capabilities. The Azure Monitor Agent replaces the legacy Log Analytics Agent, which has been deprecated. If you're currently using the Log Analytics Agent, it's important to migrate to the Azure Monitoring Agent to ensure continued support and access to the latest features. To send data across tenants, you must first enable the Azure Lighthouse service. Azure Monitor Agent also supports the Azure Service SQL Best Practice Assessments, which is currently in general availability. Needlessly collecting duplicate data increases the cost to store that data. The following cases may collect duplicate data and should be avoided. Creating multiple DCRs with the same data source and associating them to the same agent. Ensure that you're filtering data in the DCRs so that each collects unique data. The next is creating a DCR that collects security logs and enables the Sentinel for the same agent. In this case, you may collect the same events in the event table and the security event table. And the last is using both the Azure Monitor Agent and the legacy Log Analytics Agent on the same machine. Make sure to limit the duplicate events to only the time when you're transitioning from one agent to the other. Data collection rules, or DCRs, are part of the ETL-like data collection process that improves on the legacy data collection methods of the Azure Monitor. They provide a consistent method for configuring different data sources and allows you to apply transformations to filter or modify incoming data before it's stored or sent to another destination. Here are some of the best practices for creating DCRs. You want to clearly define the observability scope to make DCR management easier and more successful. This includes identifying the collection needed and the target virtual machines. Create DCRs that are specific to the observability scope, such as the set of VMs running a specific application or basic operating system counters for the IT management. Keep the DCRs as simple as possible by using fewer data sources. This reduces the management effort and the resource consumption for configuration and transformation and processing. Ensure that the list of collected items in each data source is lean and oriented to the observability scope. This helps in maintaining clarity and proper management. Transformations in DCRs are KQL, or Kusto Query Language, queries that run against each record sent to the cloud pipeline. They enable you to filter unneeded data, remove sensitive data, or format data to ensure it matches the schema of its destination. One of the primary uses of transformations is to filter out unneeded data. By applying KQL queries, you can specify conditions to determine which data should be collected and which should be discarded. This helps optimize data collection and reduce storage costs. Transformations also allow you to remove sensitive data from the collected records. This is crucial for ensuring compliance with data protection regulations and maintaining the privacy of your users. You can use transformations to format data so that it matches the schema of the destination. This includes modifying field names, data types, and structures to ensure compatibility with the target systems. Transformations enable advanced scenarios such as sending data to multiple destinations or enriching data with additional information. This flexibility allows you to tailor data collected to meet specific requirements and enhance the value of the collected data. Microsoft Defender for Cloud provides comprehensive network security monitoring capabilities. It helps you detect and respond to potential threats by analyzing network traffic and identifying suspicious activities. This includes monitoring for unusual patterns, such as unexpected data transfers or connections from unknown IP addresses. In addition to security events, Defender for Cloud also collects performance data from the network resources. This includes metrics such as network latency, throughput, and error rates. By monitoring these metrics, you can ensure that your network is performing optimally and identifying any potential issues before they impact your services. To connect your Azure subscriptions to Microsoft Defender for Cloud, navigate to the Azure portal and select the Microsoft Defender for Cloud from the menu. From there, you can enable Defender for Cloud for your subscriptions, ensuring that all resources within those subscriptions are protected. Microsoft Defender for Cloud offers various Defender plans, including Defender for Servers, Defender for Storage, Defender for Databases. And you can enable these plans to provide specific protections for different types of resources within your subscriptions. Once your subscriptions are connected, Defender for Cloud continuously assesses the security posture of your resources and provides a secure score. This score reflects the overall security state of the environment. To view information related to the resources in Defender for Cloud, you must be assigned the owner, contributor, or reader role in the subscription or the resource group that the resources are located in. Be sure to follow the principle of least privilege when assigning permissions. Just-in-time VM access allows you to lock down the inbound traffic to your VMs. This is going to reduce exposure to attacks while providing easy access to connect to VMs when needed. This feature is particularly useful for managing ports like Remote Desktop Protocol or RDP and Secure Shell or SSH, which are common targets for attackers. When JIT is enabled, Defender for Cloud ensures that deny all inbound traffic rules exist for your selected ports in the Network Security Group or NSG and your Azure Firewall rules. These rules restrict access to your VM's management ports and defend them from attack. If other rules already exist for the selected port, those existing rules take priority over the new deny all traffic rules. When a user requests access to the VM, Defender for Cloud checks that the user has the Azure Role-Based Access Control, or RBAC, permissions to the VM. If the request is approved, Defender for Cloud configures the NSG and Azure Firewall to allow inbound traffic to the selected ports from the relevant IP address range for the specified amount of time. You can enable JIT on your VMs from the Azure portal or programmatically using PowerShell or REST APIs. This flexibility allows you to manage JIT access according to your organization's need and security policies. Microsoft Defender for Containers provides comprehensive security for containerized environments, including AKS or Azure Kubernetes Services, Azure Container Instances or ACI, and other Kubernetes clusters. It offers advanced threat detection and response capabilities to ensure that your containers are secure. Defender for Containers continuously monitors your containerized environments for potential threats. It uses advanced threat intelligence and machine learning to detect suspicious activities such as unauthorized access, privileged escalation, and malicious code execution. When a threat is detected, Defender for Containers generates an alert and provides recommended remediation actions. Defender for Containers includes vulnerability management features that help identify and remediate security vulnerabilities in your container images. It scans container images for known vulnerabilities and provides actionable recommendations to address them. This helps ensure that your containers are secure and compliant with industry standards. Defender for Containers integrates seamlessly with your CI/CD pipelines, allowing you to incorporate security checks into your deployment and development processes. This ensures that security is built into your containerized applications from the start, reducing the risk of vulnerabilities and threats. Follow the best practices for container security, such as regularly scanning container images for vulnerabilities, implementing the least privilege access control, and monitoring container activities for suspicious behavior. Managed Kubernetes environments come with their own set of security challenges. It's critical to understand and mitigate threats across various instances. For example, compromised accounts can lead to unauthorized access and data theft. To prevent this, you need to implement strong authentication mechanisms. Multi-factor authentication, or MFA, and least privilege access principles are critical. Container images with vulnerabilities or misconfigurations can be exploited by attackers once deployed. Using image scanning tools to detect vulnerabilities before deployment and enforcing image provenance rules are key mitigation strategies. Misconfigurations in Kubernetes settings or deployment descriptors can expose clusters to attack. Regular audits and automated tools can help identify and rectify these issues. Applications running in containers might be vulnerable to traditional web attack vectors, such as SQL injection or cross-site scripting. Employing application security best practices and using web application firewalls, or WAFs, can help mitigate these risks. If an attacker gains access to a Kubernetes node, they can potentially escalate privileges to control the entire cluster. Keeping nodes updated with the latest security patches and restricting access using network policies are essential measures. Unauthorized access to or from the cluster can occur if network policies are not currently configured. Implementing strict network policies and monitoring traffic for anomalous patterns are crucial steps. DevOps practices aim to streamline the development and the deployment of applications, but they also introduce unique security challenges. Defender for Cloud provides comprehensive tools to secure your DevOps pipelines, ensuring security is integrated into every stage of the development and deployment lifecycle. Microsoft Defender for Cloud integrates seamlessly with the popular DevOps tools like Azure DevOps, GitHub, and Jenkins. This allows you to enable security checks into your CI/CD pipelines, ensuring that vulnerabilities and detection and remediation are done early in the development cycle. Adopting a shift-left security approach means integrating security practices early in the development lifecycle. Defender for Cloud supports this by providing tools for securing coding, automated testing, and continuous monitoring. Different permissions are required for various features. For example, to connect DevOps environments to Defender for Cloud, you'll need subscription contributor or security administrator permissions for Azure, project collection administrator for Azure, organizational owner for GitHub, or group owner for GitHub. DevOps environment security posture management in Microsoft Defender for Cloud provides an overview of how to secure DevOps platforms against a diverse range of threats. With the increase in cyber attacks on source code management systems and CI/CD pipelines, securing these environments is critical. The key points covered should be DevOps scanners that use advanced scanning to identify weaknesses in source code management and CI/CD pipelines. These scanners run checks against security configurations and access controls, providing insights into the security posture of the entire software supply lifecycle chain. DevOps Threat Matrix helps organizations discover and remediate harmful misconfigurations in their DevOps platforms. This leads to a resilient, zero-trust DevOps environment, strengthened against a range of threats and defined in the matrix. Posture management controls include scope secret access to minimize exposure of sensitive information, and restriction of self-hosted runners and high permissions to prevent unauthorized executions, enhanced branch protection to maintain code integrity, and optimize permissions and secure repositories to reduce the risk of unauthorized access. Recurring scans are auto-configured to conduct recurring scans every 24 hours across multiple DevOps resources, including builds, secure files, variable groups, service connections, and organizations and repositories. By connecting your GitHub lab environment to Microsoft Defender for Cloud, it's going to extend the security capabilities of Defender for Cloud to your GitHub repositories and resources, improving your security posture. Here are the key points you want to consider. To complete the connection, you'll need an Azure account with Defender for Cloud onboarded. You also need the necessary permissions, such as an account administrator for Azure and an organization owner for GitHub. By connecting your GitHub environment, you can leverage Defender for Cloud's security capabilities to protect your repositories. This includes threat detection, security posture assessment, and compliance checks. Microsoft Security DevOps GitHub Action is a command line application that integrates static analysis tools into the development lifecycle. It installs, configures, and runs the latest version of static analysis tools and includes SDL security and compliance tools. This GitHub action helps ensure that security is embedded into every stage of the development process by providing automated security checks within the CI/CD pipeline. So that brings us to the end of this recording, and we've covered a wide variety of the specific security deployments of Defender for Cloud that you can now action against all of the other topics that we've been covering in other recordings. And you've now seen that you go through and enable the work that you did to deploy and configure those resources inside of Azure or on premises to now report that information back to Defender for Cloud so that you can start doing the assessment, analysis, and a remediation against those resources to meet your governance and compliance requirements. That's an end to this recording, and I look forward to seeing you at a future recording.